Hello, good morning or good afternoon, depending on, of course, what time you're watching this. It's Islas Ahmed Nawaz again. Just gonna go and walk everyone through another end-to-end demo of one of the projects that I've created. So cool. Today, we're going to be talking about one of the voice agents I've created. Um, essentially, this is just a real-time voice agent running entirely off my machine and one OpenAI API key. So I can talk to it. It talks back, and yeah, I can cut it off like a real conversation. So in this video, I'm going to show you exactly how I built it and how I made the framework itself mine, including a feature. It's is it, well a feature that's was also incorporated into it. So cool. Just gonna start this session now. So let's connect. Hello. That's great. That's great. Could you tell me about the weather today? That's great. So I'm based near Staffordshire. Could you maybe find out the weather? No, that's great. Thank you. Could you tell me what you've got planned today? That's fantastic. Thank you. Cool. That's pretty much what all I want to kind of see. So I'm just gonna go through the metrics now, so you can see exactly what it's showing. Um, and yeah, so let's just disconnect from here. Cool. So essentially, a voice agent is just a loop, right? Your speech becomes text. Text then goes into a language model. The response becomes speech. It's all streaming, all latency, because a half second pause in a conversation, it feels like a broken phone line. So I'm building on Pipecat, an open source Python framework built for exactly this, but we're not gonna pip install it. I actually imported the entire framework into our own repo so that we can edit anything all the way down to the pipeline engine and more on why that matters later. And you know and it does matter, of course. So let's go to the terminal. So in our terminal, you can see we've got especially when you're running UV sync, you can see we've got Python 3.111, well 3.11 on UA, and UV handles the rest, and UV sync builds the virtual environment. Essentially stores a framework that's editable so that when I change the source, the change applies instantly. There's no, essentially reinstall. So every AI provider that isn't an optional extra. So you install only what you actually use. So if you go into the Pi project, so in here, put down the terminal. So in here, look how many providers this thing actually supports. So every one of those is a line that you could swap in. But here's a trick that makes this, quite, beginner friendly. You could say one open AI key covers all of these three stages. So you got real-time speech to text, the LLM, and the text to speech. There's one key, there's one bill, nothing else to actually sign up for. The heart of it is when we go into the actual voice OpenAI Pi file. So the full file, scroll top to bottom, you know, it's not a million lines of code, but I think main thing I want to kind of hone in on, especially is line 60. This is the whole agent. 135 lines. So four things in here matter. So here, lines 60 to 75, right? So here, as you can see, so there's first three services: speech to text, the LLM, and also the you got speech to text, the LLM, the text to speech, and all three essentially take the same API key. So you notice each one is just a class that you essentially instantiate. So the same shape for DeepGram, 11 Labs, and Anthropic. Around 80 providers, and they all slot in here identically. Different voice, change the string, different LLM company, just change the class name. One thing worth actually reading is that the system prompt, it says that your responses will be spoken aloud. So yeah, it's, you know, it says you're obviously, that's not just decoration. A model writing for a screen gives you bullet points and markdown headers. A model writing for a speaker needs, of course, short sentences and no formatting, because a human being has to, of course, say out loud. Prompt engineering for voice has its own disciplines. So then we're going to go down from line 70, 77 to about 81. Here you can see, uh, how does it know, when I've stopped talking? So we've got Silero VAD. So this is just a tiny neural network that's running locally. So there's no API call, there's no round trip, and its whole job is essentially just to listen to the audio and say that's a voice or that isn't. So it turn taking is essentially built on that. So are of course interruptions, and I'm gonna come back to that. So and it's harder than it sounds, because transcription arrives in dribbles. VAD says that you've arrived, you stopped at slightly different moments than the final transcript actually lands. So something has to decide your turn is genuinely over before it actually pokes the LLM. And that's what this aggregator does. So about 2,000 lines of code to solve a problem that sounds like collect the text. So every bad voice agent you've ever used got this part wrong. So we're gonna go into the pipeline. So if you actually look into the pipeline list, and this is the if you take one thing from this video, you take this. So your agent is just a Python list. So the audio comes in from the mic at the top, the speech becomes a text, and then the text goes to the LLM. The response becomes speech. So speech goes out to your speakers, top to bottom, of course, each line transforming, whatever the line above handed it, and that's the entire mental model. If you want a different LLM, all you have to do is just swap one line. Want every response translated into Spanish, let's say for example, before it's spoken, you just put a processor between the LLM and the TTS. Let's say you want every transcript logged into a database, same answer. It's just a list. You just put something in the list. Underneath it, we've got pipeline, Pipecat links this into a chain where each stage runs its own async task. So a slow LLM doesn't necessarily freeze you to your microphone. Well, it doesn't freeze your microphone, but you don't need to know that to use it. You just think less. So going into 90 to about 105. So yeah, um, I think the fourth thing is that I think very easy to miss these. So you got two lines that are easy to scroll past, and both are quite deliberate. So you got line 90, and then all the way up. I think the main thing I'm trying to emphasize is up to here basically, because the line 90, you got the assistant aggregator, the thing that actually writes what the bot said into the conversation history. It sits after the audio output, not before. So that ordering is on purpose. The bot's words only enter its memory once they've actually been spoken. So let's say, when you cut, when you cut it off mid sentence, half of it never actually got to say, and never ends up in the context. So it remembers the conversation the way that you experienced it, not the way it planned. So line 105, you can see, you got the processor. Just got the processor dot. It should be the processor dot end. Yeah, well, 102. So here, if a service dies mid call, you just end the session. You don't essentially limp along silently. In a voice, failing loudly beats failing quietly every time, because otherwise the user just sitting there talking to nothing. So now I'm just gonna go into the on client connected. So I last the bot speaks first. So when the browser, of course, connects this handler, then cues a message telling the LLM to introduce itself. Without it, you just both connect to silence or wait for each other. It's a tiny thing, but it completely changes how it feels. So yeah, I think that's the main thing. So I've run it, I've run it, and I'll just probably go through again. Probably show you some of the logs as well. Uh, Clear this. Get log. Just gonna show you the history. So as you can see, yeah, so these are just the commits. So I'm just keeping it upstream remote. That's obviously pointed at the original. So yeah, okay, cool. Let's just go through. I can go through the run.py, right? So yeah, it's quite a lot in here. So I'm just gonna go through the setup front end roots. Yeah, so let me just go and I'm just gonna hone into here. Yeah, so the web UI here, as you can see here, the web UI here. So what we're actually talking about here, so the web UI, is obviously Ahmed, voice agent, as you can see here, and yeah, you know, it's just a minified JavaScript inside of the package. So whatever I want to change it to, it's all cool. Um, in the Pipecat client, yeah, there's so much info here. I'm just making sure that I try capture it. There's just 10 lines in the runner. It's just an environment variable, and this just saves any custom client build that you point at it. So you've just got then two strings edits in the vendor UI, the title and flipping the logo, off. So 10 lines of Python, and that's about it. So um, let me just go through again. So let me just go through the UI. So you could say, yeah, where the question would be, where does all this go? So you got the function calling, so then that you can actually do things, your own knowledge base, so it knows all about your business. Phone calls through, um, so connect to it again. I actually, hello. Let me wake you up. Let's wake you up. Hello. Yeah. So as we can see, we have a lot of these metrics, and yeah, we got transcript here. It's the logs all here, so we got clear description of what needs to be done. We got phone options here as well. So let's just disconnect this so we don't confuse the agent. So yeah, so we got a function calling, so you can actually do this thing, your own knowledge base. If you actually want to face on it, the examples folder that I've got has a demo for nearly all of it. And yeah, the one I actually want to make sure that everyone understands is that, so we've got all the skills here as well. So it's very autonomous. So there's that example folder has a demo for nearly all of it, and the one I actually want to make. Remember when I cut it off at the start, tracing what actually happens in that half second is the single best bit of code in this repo, because the VAD fires on and essentially an interruption signal, then jumps a queue past the audio that's already buffered, and then the LLM generation gets cancelled. TTS stops, and then the output flushes. So it touches every part of the architecture, and that's hopefully the next video I'm going to be going through. So tell me in the comments if you want it, repost in the description, like, subscribe, see you in the next one.